Let's focus on a few special cases of factoring, the first one being the difference of two squares given by this formula over here. These two examples will fall into this category. So let's first talk about why this formula is true. That is, if you have a squared minus b squared, the difference of two squares, you can break it apart into this product. It's very easy to verify this formula. You can take the right side, distribute, and simplify it to the left. So let's check that out just to prove it. If we distribute, a gets multiplied to a, so we get a squared. Then a gets multiplied to this negative b, so you get minus ab. If you now multiply in the positive b, you get b times a, which is the same thing as a times b. And here you get negative b squared. And what happens is your middle terms, the negative ab and the positive ab, these two things cancel. And what you're left with is a squared minus b squared. So we have this formula, we just proved it. Let's now apply it in example 1. So starting very simple, x squared minus 25. Is this a difference of two squares? What you can look at is the first term is clearly x squared, it's very much the same thing as a squared, and then we have minus 25. Can you write that as a square itself? The first one, again, is just x squared minus 5 squared. So what we have here is that a is acting like x and b is acting like 5. If you now go up to this formula, we can simply put an x in place of all the a's and a 5 in place of all the b's to complete this process. That is, we have x minus, well, I'll put x plus 5 times x minus 5. Since we know this formula is true and we have a difference of two squares and we know what a and b are equal to, we can simply just plug them into this formula. Here, let's try this in the next piece, which is 200x to the fifth minus 128x to the power of 3. So this does not look like a difference of two squares. In fact, you have a fifth power and you have this third power. So it doesn't look like that this is going to work. But I think by looking at both terms, there's a greatest common factor that I can remove first. So let's start there. What is the greatest common factor between 200x to the fifth and then 128x cubed? The most you can take out is an x cubed, but between 200 and 128, what's the most that can come out of there? Okay, after a little bit of work, I just had a calculator here. I tried dividing numbers into both 200 and 128, and I found that the most I can take out of both of those numbers is 8. So let's remove that greatest common factor. That means you have 8x cubed, and then what is left over? Well, it would have to be 25x squared, and then minus 16. Just to check to see if this is true, if you multiply 8x cubed to 25x squared, the cubed and squared go to a fifth. 8 and 25 goes to 200, so that works. If I multiply the 8x cubed here, 8 times 16 is 128. The x cubed is just x cubed. So I'm looking at the two remaining terms. There's nothing else that can be removed. So, okay, we're off to a good start. I removed the greatest common factor, and now I can focus on, well, what about here? Can I now apply this difference of two squares formula to 25x squared minus 16? And the answer is yes. I'm going to write these two things as squares. So in my next line, I have 8x cubed, and within my parentheses, 25x squared is the same thing as 5x squared. If you square the 5, you get 25, and if you square the x, you get x squared. Then we have minus 16 is 4 squared. I don't even need parentheses. And what I just figured out is a is equal to 5x, and b is equal to 4. So again, I'm going to go back up to this formula, and in place of a and b, put these terms. Let's see what we get. So my answer is going to be 8x cubed. I'll set up two parentheses. I'm going to have a plus b, which is 5x plus 4. And then I have a minus b, which is 5x minus 4. And that's the answer to this problem. The other cases I want to consider are perfect squares. And all that means is you have a couple of terms here, all in parentheses raised to a power of 2. So like a minus b and a plus b. We call this a perfect square. If you multiply these things out, here you have an a minus b, which makes your middle term negative. Here you have a plus b, which makes your middle term positive. You could easily verify these formulas by taking this, squaring it out, and combining like terms. So we won't do that here, but you can try that yourself. What I do want to do is, in example 2, see if I can use these formulas to factor this expression here. And the goal is to figure out, well, which of the two cases does this fall into, and then what is A and what is B? Since everything is positive, it's got to be that we're talking about this here, the lower one, because everything is positive in here. I somehow want to figure out what is A and what is B. All right, if I look at the first term, I have 4x squared. That is the same thing as 2x squared. Okay, now if I focus on the last term, I have 49, and that is 7 squared. If this is to work out, A has to be 2x and B has to be 7. I just want to make sure now that the middle term, 28x, is equal to 2 times A times B. Is that true? We have 2 times 2x times 7. 2 times 2 is 4, times 7 is 28, with x left over. This middle term does in fact match up with this 28x. Perfect. I looked at the first and last term to determine A and B, and I just checked to make sure that the middle term is 2ab, matching up with this 28x, and it all worked out perfectly. Since it is of this form, I can simply go to this expression, put in place of A 2x, 7 in place of B, and write it as something squared. That is, this is 2x plus 7 squared. All right, let's try the same idea in the bottom one, 25x squared minus 60x plus 36. If this is going to work, it has to be this very first expression because the middle term is negative. So again, I'm going to look at the first and the last term to see if this is a perfect square and this is a perfect square, and then if it matches up with the middle terms. Okay, so this one's going to be, the first term is 25x squared, and okay, that's clearly 5x squared. We have this minus. If I jump to the last term, 36 is 6 squared. That means A must be equal to 5x and B is equal to 6. Is it true that if I put 2 times A times B, that this matches up with this negative 60x? So we have 2 times 5, which is 10, times 6 is 60, with an x left over, and okay, this one matches up. This is perfect. I can now go to the top formula. In place of A, put 5x. In place of B, put 6, and write the whole thing as squared. That is, this is going to be 5x minus 6 squared.